What are we going to talk about today? Today is the kickoff webinar for our webinar series called One Step Ahead in Lab. And during the webinar series, we will have different webinars and we'll cover interesting topics out of the tobacco industry and all the topics you can see here in this picture. And for today, we will talk about the moisture measurement. And we will try to elaborate on that topic by showing you a video of a test measurement of cigarettes, which we did with our MW4420. I will talk about the device a little more in a few minutes. We're not only showing you how easy it is to measure moisture with our device, but also what the device will show you as an operator. So Roger will explain the output of the device and try to give you some technical information there too. Please, if you have any questions during the webinar, don't hesitate to ask them. You can always use the chat function and type your question inside so that we at the end of the webinar can answer them or try to answer them, of course. All right. When we're talking about moisture measurement in laboratories of the tobacco industry, of course, we should also mention the traditional ones and basically the most common ones that are being used in laboratories all over the world. For example, we have the Carl Fischer titration here, which is a chemical analysis to determine the moisture content of a product or of a sample. It is a very precise method, but I think, as you can tell just by looking at the picture, it's quite complex and complicated. Then we also have here two methods that are very common in the tobacco industry. We see here in the middle the moisture balance, and on the right side a classic drying oven. Both belong to the LOD method, which stands for loss on drying, and they function very similar. And you put the product or the sample inside of the device, and the device will start heating up the product. And due to the heat, the moisture or the moisture inside the product will evaporate, and the product itself will lose some weight. And based on that weight loss, at the end, the device can calculate the moisture level of the sample. And as I said, all of the methods are being used all over the world and for years now, and they're all working, but of course they do have some disadvantages. First of all, for example, most of the time the samples have to be prepared to even fit inside the device. So cigarettes are being sliced open to take out the tobacco or filters that are cut from the cigarettes, and then the sample will be put into the device. And of course, as you can see, after the process, the samples are not usable anymore. They are destroyed and just waste. And second of all, the second disadvantage, I would say even maybe the most important one, is that all of the methods are quite time consuming. And I mean, we're talking here that one process can take up to 50 minutes plus or minus, and that is quite long for just measuring the moisture content of a product. And of course, based on that time factor, we have created a nice chart, as you can see here, and we try to compare, or we compared all the common methods in terms of accuracy, as you can see on the left-hand side, and on the duration of the process or speed of the process that you can see at the bottom. And we can clearly see that the microwave resonance technology is not only the fastest method, but also a very accurate one. And that's exactly where we come into play. And before Roger will continue with showing you our device and how to use our device, I want to quickly take a look at our device itself. So yeah, the MW4420, as you can see here, right here in the middle, is one of our laboratory devices. And just like all our devices, it is based on our patented microwave technology. And this technology allows us to measure two parameters independently, which are moisture and density, which is a very unique feature for our technology. And this technology also allows us to, or allow our devices to show you results and values within seconds. And I know microwave technology and maybe even the theory behind that can be quite complicated to understand, but I'm happy that our devices are not that complicated. And in fact, they are quite easy to operate. Of course, for first-time users, we always recommend to get one of our trained technicians to introduce the operator to the machine or to the device and show them maybe interesting or important settings. But other than that, our devices are very user-friendly. And as you have seen on the last slide, we are not only very fast, but also very accurate. And we can definitely keep up with the traditional and the other methods, and not only keep up with them, but also we are better than most of them. And I think that is a very, very strong advantage for our technology. Last but not least, and really specialized for the 4420 now here, that 4420 is very flexible, and that in terms of the applications it can be used for. So the 4420 can not only measure moisture within cigarettes, for example, but it can also give you a density profile, which can help you, for example, to detect loose ends within a cigarette. It can also help you check capsules inside your filter. So are the capsules still in the right place? Are they broken? Are they still intact? You can also use the 4420 to check the length of each segment of multi-segment filters, for example, or get the charcoal grammage of your charcoal filter. So as you can see, like this device specifically can be useful for a lot of customers and useful for a lot of purposes, which is also why we base our webinar series on this device and explain all the different applications in the near future. So now I think it's time to hand over to Roger, who will show you how easy our devices can be used for measurements of moisture.
You put the cigarettes into the feeding hopper and press the start button. The rotating feeder will grab single cigarettes and drop them into a feeding rail, which is seen here. The arm moves it through the microwave sensor, and the drop-off rail will drop it into a lower drawer. So we have two drawers on the front side. The result is displayed as graph, if you like, and here in the lower drawer you will find your cigarettes again. Yeah, we measure moisture and density at each millimeter step during the continuous movement through the sensor, and we can display those graphs and also some average values. So on the top right, you can see the overall mean moisture of, in this case, 6.84% as a result for the moisture of those 20-something cigarettes measured.
Okay, so the next topic that we will cover in our next webinar will be density profile and the loose end detection. We do not have a certain date now, so yet, but when you're interested in this topic, you can find, or we will inform you through our LinkedIn page, of course, or through email. So you will get the date as soon as possible. And we would be happy if we can see you again in the next webinar and maybe even in the whole webinar series. That's it for the moment from us. And thank you very much for your attention. We really appreciate it. But now we can start with the Q&A session. So if you have any questions, now it's time to ask, or maybe you already have asked something in the chat, we don't know. So please feel free to use the chat function and ask whatever you want. We are happy to help you with all your questions. And yeah, let's see. I think we got a question here.
This is video?
Yeah.
Wait. No.
Okay.
So we've got a question about size of cigarettes. We have those feeding slots here, and they are good to use standard and slim cigarettes, and for super slim cigarettes, we can cover these slots with insert pieces, and maybe we can see it here. Yeah, and here we have covered smaller slots for use with super slim cigarettes. So you cover the big ones and open the small ones to feed also super slim cigarettes.
Next question.
Yeah, there's a question about the colored lines on the graphs. In this case, we had, I think, 24 cigarettes. So on this print and also on the display of the machine, we always have the green line for the average of the amount of cigarettes, those 24 cigarettes, at each millimeter position. So that's the green line. And optionally, we can display or hide red lines for maximum and minimum density and moisture at each profile position. And there are another set of blue lines for the standard deviation, which for my feeling are too many lines displayed on the graph. The next question is about calibration for moisture and for density. The MW4420 comes with a built-in standard calibration on the microwave subsystem, but to adapt it to your need, you can modify the moisture by an plus-minus offset, as well as for the density in the brand settings. So using the standard tobacco calibration for all products, for each kind of cigarette which you teach the instrument in the settings, you have individual offsets which you can set. So by taking reference methods for your kind of cigarette in oven or something else, you can determine the discrepancy between our standard tobacco reading and the reference value, and program the 4420 to always keep that offset or to compensate this offset as a calibration. Okay.
Are we back again? Hopefully.
Okay, there was a question about annual costs, maintenance costs. We don't have a fixed plan, and there's no periodic maintenance needed. The instrument is running spare part or wear and tear free, basically. But optionally, you can invite us to come to your place for a checkup on any period you like, yearly or 2 yearly, if you like. But in most cases, the 4420 will run trouble-free.
Good. Okay. So I think we hope that we answered all your questions, of course. And if you still have some questions for us, feel free to contact us directly. Our contact information should be in the chat. And yeah, we're trying to help whenever we can, so feel free. Thanks again for your attention today and for your time, of course. I hope it was interesting for you guys, and we also hope that we will see you again next time. And yeah, with that, I would say thank you for your attention and have a good rest of your day.